Claim X for a dental insurance is random variable with probability function given below. Premium for policy is 125% of expected claim amount. Calculate the approximate probability that the total claims on 76 independent policies exceed the total premium collected. So we will calculate the expected total premium on 76 policies, and then we will need the probability that the total claim is greater than that expected total premium. So X is the claim amount for a single policy, and here's this distribution. So we start by first finding the expected value of X. So the usual formula, summation of XFX, so 0 times 0.5 plus 1 times 0.2 plus 2 times 0.3, so E of X is 0.8. And by the central limit theorem, the expected claim on 76 policies would be 76 times the claim on single policy, so 76 times 0.8 is 60.8. And the expected premium, since that's 125% of the expected claim, so the expected premium on the 76 policies would be 1.25 times the 60.8, so that would be 76. And now we go about finding the standard deviation of X, for which we first need E of X squared. So that would be 0 squared times 0.5 plus 1 squared times 0.2 plus 2 squared times 0.3. And 0 squared is 0, 1 squared is 1, 2 squared is 4. So we get 1.4 for E of X squared, and then variance of X is E of X squared minus EX whole square, which would be 1.4 minus 0.8 whole square, that's 0.76. And if we let S be the total claim on 76 policies, because remember, we have to find the probability that the total claim on 76 policies is exceeding the total premium. So if S is the total claim on 76 policies, then the standard deviation of the sum according to central limit theorem equals square root of n times standard deviation of a single policy. So square root of n here means square root of 76 because there are 76 policies, and standard deviation of single policy will be the square root of the variance of a single policy, so square root of 0.76. So we get the standard deviation of the sum to be 7.6. And the question was to find that this sum total claim exceeds the total premium on the 76 policies, which we calculated to be 76 over here. And so we have to find probability S greater than 76. Therefore, we need to change the 76 into z-score. So that would be 76 minus the mean, which is 60.8, divided by standard deviation, just 7.6, and that comes out to be 2. So therefore, probability S greater than 76 equals probability Z greater than 2 equals 1 minus probability Z less than equal to 2. And from the table, the cumulative probability of 2 comes out to be 0.9778. Let's magnify this. So for 2, we can see 0.9772. That's the cumulative probability for Z equals 2. And therefore, the result is 1 minus 0.9772, which is 0.0228, and that is choice A.